Let's take a look at what I'm talking about here. So we have an input x and we have an output f of x. You can make up whatever you want to represent this data. This could be the number of degrees Celsius it is outside, and this could be the amount of money in my bank account. I don't know, those things aren't really related, but you get the idea. There's some input and there's some output relationship here. Notice the table is complete for the top three here, but it's incomplete for the last one here. What we want to do is fill out the last entry in this table. And we also want to graph this also. We're going to graph it as well. And I'm telling you ahead of time, it's a linear function. You can't really do this if you don't know this is already a linear function. But you could work under the assumption it's a linear function and then graph it and make sure that your assumption is correct, that it is a line, and then you'll know that you're correct. So it's not like you're guessing. You just kind of assume it's a line, and then assuming that you plot it and it is a line, then your assumption was correct. So a lot of students will look at this, especially on an exam or something, and they'll just try to make up numbers that fit in here that might make sense with this. And there are many ways to solve this. Actually, I know of another way. You could use ratio and proportion to solve this problem as well. But that's not the point. We have to learn and use the skills that we're learning here because they'll be applied to other things later. Okay, we're going to solve this using equation of a line. We know that all of these points must go through a line because we're studying linear functions. So what we want to do then is recognize that this is going to be a function, f of x. And it's going to be some m times x plus b, right? Now, I don't know much of anything about anything, but I do know that I have multiple points here, x comma f of x or x comma y, and so I know I can find the slope. It's always a good strategy if you know that you can find something to go ahead and find that thing. And we know in this case that we can find the slope, and I can use any of these points I wish. So I'm going to calculate the slope using the top 2 points here. So let's go 3 minus the negative 2. You can subtract in any order you wish. Since I'm going this way, I'll go negative 2 minus a negative 7. I know all the double negatives aren't great, but that's what they are. So this works out to be 3 plus 2 on the top because add the opposite here, and negative 2 plus 7 on the bottom. So what we get here is a 5 on the top, and on the bottom we get also a 5. 7 minus 2 is 5, and so the slope is equal to 1. Let me just double check myself here. The slope is indeed equal to 1 for this problem. So what we can do is take and put that slope into the expression or the equation of the line that we have, f of x, is equal to 1 times x plus b because m is equal to 1. But usually we don't leave the 1 there. That's just a coefficient of 1. So really we'll write it like this, x plus b. This is really getting pretty close to the equation of the line for this situation, but we don't know the y-intercept. But we already learned in the last lesson how to find the y-intercept. We know the equation of the line, everything except the y-intercept, and we know we have 3 separate valid points. All of these points have to lie on the line. So I could put this set of values into that equation. I could put this set into this equation. I can put this set into this equation. They will all give me the same, they'll all be correct. They'll all be able to be used because they're all on this line, okay? So I can put whatever I want in there. I'm going to choose to put the third one in there, but if you want to put the first one or the second one, that's fine too. The output f of x is 8. When the input x is 3. So I'll put a 3 in there, and now I can figure out what that y-intercept is. All right, I'm going to subtract 3 from both sides. Because I subtract 3, it goes away. Here I get a 5, so the y-intercept is equal to 5. Now we learned from the last lesson that the y-intercept represents the initial condition of whatever it is we're studying. So that's what it is. Now, putting it all together, we now know that my function must look like this. We said f of x is x plus b because the slope was 1, so it's going to be x plus, but now we know b is 5. Whoops, I don't want to put a b there. I want to put the 5 there because we now know that the y-intercept has to be 5 here. This is the equation of the line. We can graph this right now. We know the slope is 1. We know the y-intercept is 5. But before we graph it, we want to use it to fill out this table because this table is a table of inputs and outputs. If we stick the input in of negative 7, we should get a negative 2 out. Go ahead and do it. Put a negative 7 in there. Negative 7 plus 5 is negative 2. That's the output. Let's put a negative 2 in there. We put a negative 2 in there. What do we get? Negative 2 plus 5. That's going to give you a positive 3. That's the output. What if we put a 3 in there? 3 plus 5 is 8. That's the output. You see, it predicts everything in the table. Now let's use our last one. Let's put a 5 in there. And the way you say it is the function f evaluated at x is equal to 5 is equal to 5 for the value of x plus 5. So the function evaluated at x is equal to 5 is equal to 10. And so 10 goes in our table right here. So this is really the answer, or part of the answer. We wanted to figure out what the function was, which is this, using the slope and the y-intercept. And we wanted to use that to predict the unknown value of the table, which we've done. Now, let's go ahead and plot these on the table. Let's connect the dots, and let's see if the equation of the line that we wrote down actually fits with the data here. So we have -7, comma, -2. So we're going to graph this here. -7, comma, -2 is right there. The next point was -2, comma, +3. So -2, comma, 1, 2, 3 is right here. And then the next one after that is 3, comma, 8 and 5, comma, 10. So 3, comma, 6, 7, 8, and then it was 5, comma, 10, which is way up here, like this. And you can see that this is going to form some sort of line. So let's connect the dots and see where it lands. All right, so here we go. Here is my straight edge. I'm going to do my best to get it to go through all of these dots through the center of them, even though it's not going to be perfect. The better job I do with that, the better my graph will be. Get it perfect is basically impossible. All right, so let's go through all of these points. You can kind of extend past if you want to show that it's a line like this. So the little double arrowhead there. And let's see if it makes sense. Obviously, it forms a line, goes through our points. We said that the equation was f of x is x plus 5. So f of x is x plus 5. How do we graph this? The y-intercept is 5. 1, 2, 3, 4, 5. That's the y-intercept. The slope is 1. That means rise over run. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. You can see the slope is 1. This is the correct equation of these data points that goes through these data points, predicts the y-intercept, and so once we know the equation or the function for this line, this linear function, we can use this function to predict any other point on this line, and that's what we did. We used it to put in this value of x and predict the correct output, 5, comma, 10. You can see 5, comma, 10 does fall on this line, and so it is, we did the problem correctly, is what we're trying to say. All right, let me take this down. Let's do our second problem. All right, let's take a look at problem number 2. We have inputs, which are these numbers here, and then we have the corresponding outputs, f of x, here. And so we know, again, we're assuming in all of these cases that we have a line here, a linear function, mx plus b. That's what we're assuming for every single problem here. So the first step is going to be to find the slope of this line. So we can use any 2 points we wish. Let's use these 2 just to do something different. So we'll go this way, 1 minus the -5. 1 minus -5, that's the rise. And we'll go the same way, -2 minus 4. All right, so this is 1 plus 5 right here, because the double negatives here. And then we have here -6. So what we actually get is a 6 on the top and a -6 on the bottom. So the slope is actually -1 in this case. So we get a slope, let me just double check myself, yes, of -1. Now let's take that slope and let's stick it into our equation for a function of our line. So it's a -1, so it's going to be a -1 times x. I'll write it as -x plus b, because remember there's always an invisible 1 here, so this is -1 times x plus b. So in order to figure out the unknown value of this table, we have to have the full equation of the line, the full function for the line. We need this y-intercept. So what we'll do is we'll grab another point out of this table. Let's pick -2, comma 1, and we'll stick it into this equation. The output is 1, goes here, when the input x is -2. But notice there's already a negative here, and then x is a -2, so you really have a double negative there, right, plus b. So 1 is equal to, this makes it a +2 plus b. And so what you get when you subtract 2, 1 minus 2 is equal to b. You subtract 2 from both sides here. b is -1. b is -1. So then what is the function, the equation of this line? It's f of x is equal to -1 times x is -x, and then plus b. But b is actually -1, so it becomes -1 right here. So this is mx plus b, but the b, the y-intercept, happens to be negative in this case. So the first step here is to write the function for the line that represents these data points, and this is what it is, -x minus 1. M is the slope, -1, times x plus b, which means the y-intercept is -1. Now the last part of the problem is to predict. We can check a few of these, by the way. Let's put an input of 4 in here and see what happens. If we put a 4 in here with -4 minus 1 which means -5 comes out on the output. So it works to that point. We could check the other ones if we want. Now we want to put 8 in. Let's put 8 in here. The function f evaluated at x is equal to 8 is equal to negative sign, 8 goes in here, -1. And so this function evaluated at x is equal to 8, -8 minus 1 is -9. And so the output of this thing is -9 right here. So what we did is like a 3-step process. The first step is we figure out what the slope is. The second step is we put it into the equation. The third step is that we use another point, any other point on the line, to put it in here and figure out what that y-intercept is. Once we have the function for the equation of this line, we can use it to predict any other point on the line. So we use it to predict when x is 8. The output comes out to be -9. Now, the last part of what we're going to do here is graph it and see if what we graph makes sense. So we have -8, 7 here. -8, 7. So here's -6, -7, -8, +5, 6, 7. So the point should be right there. And then we have -2, +1. -2 is here, +1 means the second point is right here. And then we have 4, -5. Here's 4, -5 is way down here. And then the last point, the one that we predicted here, is 8, -9. And that should be on the line as well. 8 is right here, -9 is right down here. You can see these look like they're all lined up here, but let's connect the dots and let's also verify that the function that we used actually does predict all of these dots, that the equation makes sense. All right, so let's draw this line. Goes through all of these points. And what does it look like? Let's take a look. So we said that the function for these points, -x minus 1, we said f of x, -x minus 1, mx plus b. So the y-intercept is -1. That's exactly what we found. The y-intercept crosses exactly at -1 on the y-axis. Slope is -1. That means down 1 over 1. So down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. You can see the pattern continues. So we have used the data from the table to find the slope and to find the y-intercept. Once we have that, we can write down the function, which is in mx plus b form, a line. When we draw the actual points from the table, including the one that we found ourselves, they form a beautiful straight line. We draw that straight line, then we verify that the line that we drew from that data goes through the correct y-intercept with the correct slope, so everything is self-consistent. You see, this point here, the y-intercept, is not in our table anywhere. X is 0 is not in our table, but if it was, it would be x is 0 and y is -1. But we know it's right because we know that this equation has a y-intercept of -1. All right, so this takes a few times. If you're just starting to kind of understand, that's okay. We have 2 more problems and we have more. It takes time. So let's take this one down. We'll do another one. Continue building your skills. All right, we have 2 more problems. Here's our next one. We're going to try to figure out what the unknown value is here in this table for the output when input is equal to 10. We're not going to graph these because we've done enough graphing. We just want to do the math to figure out what this is. So we have to figure out the function for the linear function, the equation of the line that represents this data. We know that it's going to be f of x is mx plus b. Write it down every time. And then we know that we can find the slope because we have multiple points here, and we only need 2 points. So I'm going to pick these 2 points just to make it, it's not really easy, but I'll just do that. 103 minus 43. Subtract the y values, right? And then after that, it's going to be 7 minus 1. 7 minus 1. So what I'm going to get here on the top is 60. On the bottom, I'm going to get 6. And so the slope here is going to be 60 divided by 6, which is going to be 10. So that's the slope. And then I'm going to grab this slope, and I'm going to stick that slope into this equation, f of x. The slope is 10 times x plus b. Now I have almost the whole thing. How do I find this unknown? I have to put an x and an f of x value. I have plenty of them to choose from. I'm going to put, oh, it doesn't really matter. I'll put 1, 48. So the 43, sorry. The output is 43 when the input x is 1. So 10 times 1 plus b. So what you have is 10 here. So 43 is equal to 10 plus b, and then we solve for b. 43 minus 10 is equal to b. Because we subtract 10, it disappears here. b is 33. The y-intercept you figured out is 33. So then we put it all together. The function f of x is m10 times x plus b, which is 33. So 10x plus 33. So that's kind of like part of the answer. But it's not really the full answer. What we really want to do is predict what's in this table. When the input is, well, let's just check one of these. If the input is 1, then 10 plus 33 is 43. That works. And you can put the other points in as well. Let's put the input value of 10 in here. So the function evaluated when x is equal to 10 means 10 times 10, because we put the value of 10 for x. We have to add that 33. So the output is going to be, this is 100 plus 33, 133. So when the input is 10, the output is 133. So 133 fits in this table. And that's the final answer. Usually what we do is we graph it and we check it and all that, but we've done enough graphing. We don't need to do any more graphing. We just need to find the equation for the function of the line, use it to predict an unknown value in this table. Input, output, like this. We'll do one more and then we'll be complete. All right. Take a look at our last problem. Again, lots of weird numbers, inputs, outputs, but it's a linear function for all of these. So go through the motions again. F of x, mx plus b. Like this. All right, now we first find the slope. The slope of this line. You can use any pair of numbers that you wish. I'll use this one here, 110 minus 50. Subtract the output values, the y values, if you want to think of it that way. Since I went this way, I'll go this way over here, 80 minus negative 40, which means 110 minus 50 on the top, plus sign here, because the double negatives make a positive. So what I end up with is here I'm going to have go down by 10 is 100, and then minus another 40 is 60 on the top, and here I have 120 on the bottom, and 60 and 120, you divide, you can see that that's 1/2, so you're going to get a slope of 1/2. So the slope of this thing is 1/2. Right, now that we know the slope is 1/2, then we continue on. M is 1/2, because the slope is 1/2, x plus b. Now to find the y-intercept, we can pick any number or any point that we want to. I'm going to choose this one here. It doesn't matter. You can pick any of the other ones. The output is 110 when the input, x, is what? 80 plus b. So what is 1/2 of 80? It's 40. And how do I finish the rest of the problem? I need to subtract 40 from both sides to solve for this guy. So 110 minus 40 is equal to b. Subtract 40 from both sides. So I have 100, and then 30 more means 70, so b is going to be equal to 70. And that's going to be the y-intercept. Now that I have the y-intercept and the slope, I can say that f of x is equal to the slope 1/2 times x plus 70. This is like half of the answer. It's basically figuring out what the equation of this line is, 1/2 x plus 70. And then what we want to do for our final answer is we want to predict the unknown value here in the table. So when the input is 220, what happens? So the function evaluated when x is 220 means that I'm taking 1/2 of the input value of 220, and then I'm going to add 70 to it. So what I'm going to have, 1/2 of 220 is going to be 110, and I'm going to add 70 to it, and then the output value is going to be 180. So when the input is 220, the output is 180. So I'll put it like this. When the input is 220, the output calculated to be 180. So 180 goes into our table, and that's the final answer. If you were to graph all these points, which you could certainly do, they would form a straight line. The y-intercept would be at 70. The slope would be 1/2. You would see and convince yourself, just like we did for the first two problems, that it formed a nice, beautiful straight line there. So I'm hoping that by the end of this lesson, even if you're not totally sure, maybe if it's not fluent, but at least you can follow my steps and you know what I'm doing. Notice I'm doing the same thing every single time. And we're doing 4 problems in this lesson. We'll do 4 problems in the next lesson to really drill it home. A lot of times teachers will teach students these little shortcuts. Hey, do this, solve that. Just do this, use this equation. Don't worry about what you're doing. Notice I'm not doing any of that. I'm not blindly telling you to calculate something. All I'm saying is, okay, we know we can find the slope, find it, great. We know it has to be a linear function, okay, so stick the slope in there, great. All right, now that we have this, we know that any of these points have to be able to satisfy this, so we stick them in there. and then we use algebra to figure out b. Great. Once we have this, the intercept and the slope, we can write the linear function down, and then we can use it to predict anything we want. Notice there's no formulaic, just do this and you'll get the answer. It's all logical, because this, if you know what you're doing, then you're not just making up stuff. You're following logic instead of just following recipes, I guess is what I'm trying to say. When chefs, I'm not a chef, okay, right? But I do some amateur cooking. A real chef doesn't follow recipes, all right? A real chef just has a great feeling for what works together, and logically that, certain things are going to go good together, and certain things like chocolate and I don't know, snails, I don't know, maybe they do go together, but they don't sound great to me, right? Some things are just not going to go together. Mayonnaise and chocolate, not going to go good together. And a real chef can put things together that make sense because of experience and intuition without following cookie cutter recipes. That's what I'm trying to teach you. That's why you're not seeing just follow this equation and you'll get the answer for lines. Like, it's not like that. I want you to know what the intercept is, what the slope is, what it means to have a function, input and output, so that you can put it all together in various ways, because all the problems I'm showing you now, I guarantee you'll find one that doesn't fit into this category, but you'll know what to do because you'll know what you're doing. So solve these. Follow me on. We'll get a little more practice in part 2 with writing linear functions. We're using a table of values. Learn anything at mathandscience.com.